Hello, my name is Joshua Devier from Covington, Louisiana, and I'm here to tell you about the immune system.
The immune system is a complex array of cells and chemicals that keep the body protected from threats foreign and domestic. It is divided up into two portions, the specific and the nonspecific. The nonspecific immune system is composed of general barriers to infection. The skin is an example, providing a physical barrier to block the entry of pathogens. The eyes are another example, as they are coated with what is called lacrimal fluid, aka tears that contains lysozymes. These lysozymes, also called meramidases, are found in the sweat and break up bacterial cell walls. Cells in this category include neutrophils and mast cells.
Next up is the adaptive specific immune system, composed of the humoral and the cell-mediated responses, both of which can be provoked by antigen-presenting cells. These macrophages and dendritic cells engulf the pathogens and digest them into smaller pieces. These pathogenic antigens are presented to passing immune cells using the class II major histocompatibility complexes. Passive helper T cells interface with these presented molecules, and if they do not match up with their beta-base, they activate. Like any gossipy cell, they get their friends on their side. With signaling protein interleukin 2, the helper T can activate other helper Ts and the two aforementioned specific responses. When the humoral response is activated, B cell replication increases first. The B cells, like all cells, form proteins from DNA.
By systematically scrambling their DNA in the process of VDJ recombination, the proteins can too be scrambled. These Y-shaped proteins are selected for in order to neutralize antigen interactions. Presented on the cell surface, if these Y proteins are interacted with, hopefully without self-interaction, the B cells will differentiate into plasma cells to produce free-floating antibody molecules that can, for example, neutralize bacterial toxins or stop viral entry.
On the other hand, cytotoxic T cells are activated in the cell-mediated response. They screen other cells by mashing with the MHC class I receptors that scoop up internal proteins. The quality control check can occasionally turn up things like viral proteins inside the cells that indicate illness to T cells. In order to shut down the cellular threat, the cytotoxic T cell releases perforin and granzymes that let themselves into the cell and initiate apoptosis, orderly cell death. The adaptive immune response sets aside memory B and T cells in order to remember the specific task to defeat the first pathogen in case of reoccurrence. Vaccines capitalize on this system by training the body with a pseudo-threat that prepares it for the real one, such as clonal selection beforehand, but it can also protect against cancer cells. The immune system can differentiate and attack neoplastic tissues, however it can face challenges due to the similarities of healthy tissue and what used to be.
The immune system also faces issues with self-identification, occasionally mistaking its own healthy cells for pathogenic tissue and threats, inducing an autoimmune response, such as lupus and multiple sclerosis. The immune system is an incredibly complicated biomachine that allows for big organisms to efficiently protect against micro threats. I've been Josh, thank you for watching, bye-bye.